Hello everybody, get ready to do lesson 13.6 of Pre-Algebra Math, part 1 today. And we got a 34-point classwork sheet, skill sheet, 34 points. And we have 20 points here of note taking. Rotations and symmetry now is what this lesson is about. Today's bell work teachers. We have multiple choice here. Each leg of right triangle is length 3 inches. How many lines of symmetry does a triangle have? You would have covered this in part 2 of 13.5. And then the least common multiple of the numbers here, students. Give your students 5 minutes, or 4 minutes actually. Okay, welcome back. The triangle has one line of symmetry here, so we draw it through the right angle here of this right triangle. These would both be symmetrical. Both sides of this line would be symmetrical. And then, so it would be A. And then find the least common multiple of the numbers. It would be 60. And here they are multiplied out. And the LCM of 4, 12, and 15 would be 60. Okay, into our lesson today, 13.6, you translate reflected figures. You'll rotate and identify rotational symmetry. A rotation, in this classwork, page 1, is a transformation in which a figure is turned about a fixed point called the center of rotation. The angle of rotation is formed by rays drawn from the center of rotation through corresponding points on an original figure in its image. The direction of rotation can be clockwise or counterclockwise. So you can rotate this way or that way, and the angle is rays drawn from the center of rotation, kind of like the vertex of a triangle or something. This is an example here of a rotation. Center of rotation would be here, and then you're moving clockwise in a 45-degree fashion there. And then this would be a counterclockwise example here of a rotation. So you're starting here and you're moving 120 degrees that way. Students, this is your definitions now of a rotation. And then a center of rotation, 10 points. I check this on Fridays if you're in my classroom. That's what I do. And then we have angle of rotation here, and then rotational symmetry. We haven't quite covered that yet. Hang on to that. We're going to get to that. Okay, into our first example here, identifying rotations. Tell whether the transformation is a rotation about the origin. If so, give the angle and direction of rotation. So we have a situation here. Is this a rotation about the origin? And it's a 90 degrees rotation. So we go from quadrant clockwise, actually. So it's 90 degrees clockwise. We're going from quadrant, see, this is quadrant 3 up to quadrant 2. So we're moving in this direction here, and it's rotating as well as moving up one quadrant here. It's a 90 degrees clockwise rotation, and then here is our original. This is our image. What kind of rotation is that? It's not a rotation because it looks like more of a, see, this is down here. It looks more like a shift. This would rotate like this and then rotate again, and that would not be what this figure would be like if it was a 90 degree and then 180 degree. This would be like a 180 degree rotation here. And it's a shift is what it is. It's just a shift. It's not a rotation. And then we have this situation. Here's the original, and then here is the image. It'll be 180 rotation in either direction. So you either go this way or this way to get this image of this original here in a rotation. So this goes 90 and then another 90. So in that situation, this is kind of like, this would be the long side here and it's flipped up. And this would be a 180 degree rotation of the original here is what it would be. And you can go either way for that. Okay, use a coordinate notation to describe a 90 degree clockwise counterclockwise rotation. Use coordinate notation to describe a 90 degree counterclockwise rotation. Then students tell whether the transformation is a rotation about the origin. If so, give the angle and direction of rotation. Here's the original, then this will be your image here. Tell us if that's a rotation. Okay, for our guided practice up here, it'd be x, y, and then negative y, x, because it would be a coordinate notation to describe a 90 degree counterclockwise. So we would be moving in a counterclockwise position. So it will be a negative y and then an x, moving from a positive, which would be quadrant 1. This would be a negative y, so it would be in quadrant 4 is where that would be. So use quadrant rotation to describe that. Okay, into our next page here of our classwork, page 6. 90 degree rotations. All rotations in the coordinate plane are centered at the origin. You can use coordinate notation to describe a 90 degree rotation of a figure about the origin. So this would be a 90 degree clockwise rotation here. You have a prime would be 3, -2, and then 1, -3 from this situation here. So a rotation is when you change positions of your x and y, and then you negate your x to become your new y is what it becomes here. So this x is now a -3y, and then this x is now a -2y. And then this would be an example here of a 90 degree clockwise rotation. Switch the coordinates and multiply the new y coordinate by -1. So you have this situation here, y and then -x. And in this situation here, a counterclockwise rotation, how do we get that? Switch the coordinates, then multiply the new x coordinate by -1. So we switch coordinates from here. This becomes 1, 3 now, and it's -1, 3. So it'd be -1 and then 3 up here. And then this would be switched again. It'd be a -3, 2. So switch the coordinates and multiply the new x coordinate by -1 in this fashion here. So the xy would become -yx. So the -y would become the new x, and the x would become the y. It could be a little confusing. Be careful with that. So example 2, rotating a triangle. Draw ABC, triangle ABC with these vertices here. And then this is the vertices here of this. Then find to rotate ABC 90 degree clockwise, switch the coordinates and multiply the new y coordinate by -1. So this would be a rotation here in a clockwise position from ABC. This would be the new triangle here. It's rotated 90 degrees. So here was the original -3, 4 for A, -3, 4, and then the new A prime would be 4, 3. So we flip this, and then we multiply our new y by -1. So, and then etc. down here. This would be the rotation coordinate here for the image from the original. And then you can draw that here on your own. And on your classwork sheet, you will have that chance to draw these on your own. Okay, our guided practice here. Find the coordinates of the vertices of the image of prime A, B, and C after a 90 degree clockwise rotation. Draw the image of A prime ABC. How are the coordinates of the vertices of A double prime BC related to those of triangle ABC? In example 2, find the coordinates of the vertices of the image of ABC after a 90-degree counterclockwise rotation, then draw the image. So this is your students. We're going to do this one now. They got practice. So here is the image. Here's A prime. This is an A prime. This is one rotation here. And then A double prime is here. We started here, we went to here, now we go to here for our guided practice. And then this is the original. The coordinates of vertices of A double prime, B, C are opposites of the coordinates of the vertices of ABC. So this is the opposites here thrown over into this quadrant here from over here. And that is 13.6, part 1, part 2, part 3, available at this email here. Thank you very much.